there. Today we are talking about inequalities. And inequalities are similar to equations, except that they are the less than or greater than situations, not actually equal, but unequal. And before we jump into trying to solve some, we do need to make sure everybody's on the same page with notation. I mean, there's kind of this graduation of getting as you get into higher level math of what the typical notation is. So like you talk about number lines from early days. And so here's a number line. Then it kind of starts to deal with inequality notation in Algebra 1 and maybe even Algebra 2. And so let's look at this number line. We're going to write it with an inequality. And then really what we do in college algebra is use interval notation. So inequality notation, when you look at this graph, basically -2 is the key point, and you want everything that's less than that, to the left of that. So you would write something like x is less than, now notice that's a closed dot. That closed dot would mean or equal to -2. There's your inequality notation. If you were to write that as an interval notation, when I'm doing interval notation, I always think of this number line in my head. I'm always thinking of that because in interval notation, there's two values you need. You need the lower bound and you need the upper bound. The lowest it can be, the highest it can be. So the lowest is going to be -infinity. The highest it can be is -2. Now, it can't really equal infinity because that is not really a number. That's always a parenthesis. But because of the closed dot, it does actually hit -2, so we do a bracket. So recall that if it can equal it, we do a bracket. If it can't actually equal it, we use a parenthesis. And in fact, this whole idea of parentheses and brackets is also now used on a number line. So typically, instead of using a closed dot, you'll see it with a bracket on it instead of that closed dot. And that's just a hint to you to be using a bracket. Okay, let's look at another scenario. This time I'm giving you the inequality notation. So you want everything that's greater than -6. So here's my -6. You should have an open dot because it's not an or equal to, and everything greater than that. And again, instead of the open dot, you might see it like an open parenthesis, and then everything to the right. Now with that vision in my head of that number line, I can see that the lower bound is -6, the upper bound is infinity. I would do a parenthesis on both of those because there's not an or equal to happening. Now let's get into something weirder. We've got what we call a compound inequality because you have two inequalities. It's separated by the word or, which means maybe there's not going to be any overlap. It's like this or that. M is less than or equal to -6. So because of the or equal to, I'm going to put the bracket or the closed dot, and it's everything less than that. Or M could be greater than 3. Okay, so greater than 3 would look like this, parenthesis and this, or an open dot. And just like that's sort of messy in how it's written, even my interval notation is a little bit messy because I'm going to have two separate intervals. I have this chunk and I have this chunk. So this chunk is -infinity to -6 with a bracket. And then we use this U shape. It means in union with, together with. So I've got this interval together with the next interval, which is a parenthesis, 3 to infinity. There's not really an easier way to write those compound inequalities that go like opposite directions like that. Now, my next situation is another compound inequality. It's a little bit nicer because it's everything in between these two values. To write that in inequality notation, you'd write your -8. Well, really, you'd put your x or whatever letter in the middle. It always goes in the middle. And then you have your -8 as your lower bound, and it looks like -1 is your upper bound. And you always put in less thans, because what that indicates is that x is bigger than -8, but x is smaller than the -1. Sometimes people point these like, I don't know, they go like this with them. Nope, they both point the same direction. And they're both closed dots, so they're both or equal to. Even easier, interval notation. Lower bound, -8. Upper bound, -1. All right, so probably in your homework, we're supposed to be using interval notation most of the time, but you're going to see this in the process of solving, so you've got to be able to jump in and out of the forms. We're going to start with some basic equations here that takes you back even to Algebra 1. I'm going to go fly through these pretty quickly. I'm just going to solve them and talk as I go. One thing you have to worry about with these linear inequalities, notice these are all linear. We're going to jump into quadratic here in a second. These are linear. When you multiply or divide by a negative, don't forget to flip the inequality sign. All right. First one, just nice basic two-step equation. I'm going to isolate the x. I'm going to subtract the 3, divide by -2. Because I'm dividing by a -2, my inequality switches. Now it does say use interval notation. So this is what's going on in my head. Here's my -4, and it's everything bigger than that. So my interval notation is -4 to infinity. It does not have an or equal to, so these are all parentheses. Okay, next. Now we're going to start with quadratic inequalities, but this method that we're using for this can be used for any equation, really, or in any inequality. And so I kind of got a little to-do list for us here to work through this. The first thing we're always going to do is just solve the quadratic like it was an equation. So that means factoring, quadratic formula if we have to, but I think they're going to factor usually for us today. Then we're going to use a number line. And maybe I should make a note right here that when you solve this, what you are finding are what we call the boundary points or the critical points. And these are going to be points that we then put on our number line. And like if you factor it, you're going to have 2 boundary points, which is going to create actually 3 sections on your number line. And then you're going to put test values in each one of those sections to see whether it works or not. All right, let's just jump in and try it and see. That's sometimes easier. I'm going to begin by going ahead and factoring this quadratic. Now, in this factored form, this is actually the form that I want to use, this one right here. I'm not going to really look back at this one hardly at all. So what's going on here, I guess what you have to realize is that you are taking this quantity times this quantity, and you want it to be less than 0. So tell me, what's going to have to be the case with these 2 quantities for it to end up being less than 0, or negative is really what that means. Well, one of these quantities will have to be positive and one will have to be negative. They have to have opposite signs. That's the only way you're going to end up with this being less than 0. If this quantity and this quantity are the same sign, then it's going to end up positive and this will not hold true. That's going to be my strategy, is to figure out how do I force both of these to have different signs. Well, I'm going to find these boundary points. So that's -3 and 4. And then I'm going to come over here and I'm going to create this number line and put those boundary points on it. And I'm going to do a test value in each area. I'm going to start off on the left and I'm going to plug into, and I am plugging this into this inequality right here. I'm going to undo that and I'm going to redraw that. It's really, I'm plugging it in over into there, plugging it into those. So I'm going to do F of, and I'm going to pick some value on this end. Now I could go ahead and pick just -4. I could pick -10, whatever I want to pick, as long as it's on that side of the -3. I guess I'll just throw in a -5 for no particular reason. What that means is I'm going to put a -5 in for this X and for this X. Now, what's nice about this is that we aren't really concerned about what the numbers are. I'm not really having to figure out and evaluate it. All I really care is if it's going to be positive or negative. If you put a -5 right here, you're going to have a -5 plus 3. I know that that's going to end up being negative. So what I do is I put a little negative sign here. Now I'm going to plug it in to the second quantity. When I put in a -5 here, -4, that's also going to end up negative. And if I take a negative times a negative, it's going to end up positive. Now I'm going to do, I just do that same thing. I'm going to do F of, pick some value in here. 0 is going to be the obvious choice. When I plug 0 in, right here, that's going to end up positive. Plug 0 in here, that's going to end up negative. I have a positive times a negative, and that's going to end up giving me a negative value. Let's try one more test point over on the right side of the 4. So let's put in a 5, I guess, and plugging that in. If I plug 5 in here, this will be positive. Plug 5 in here, this will be positive. If I take a positive times a positive, I'm going to end up with a positive. Well, now what I'm doing is I'm identifying exactly what it is that I'm shooting for. And remember, I'm shooting for this. Oops, let me undo that and change colors a little bit. I was wanting to kind of highlight this. This right here, I'm trying to highlight, means that I want it to be less than 0. I want it to be negative. So this right here is going to be the scenario. In fact, all this is what I want to have happen, which is happening right in here. That's the connection that I need to make. Any value that I choose within this range will make this inequality true. And I highlighted here, I really probably should have highlighted right here, because remember, this is where I'm looking. What I have found is the solution to the inequality. Anything in this area will keep this less than 0, which is my solution. All right, so final answer, my solution is any value between -3 and 4. Notice that it's not an or equal to, so I want parentheses on it. And that's my solution. Now I kind of slow played that, went through, tried to have it make sense in your head. It really doesn't need to take us quite this long. I'm going to kind of show you on the next one, maybe a little bit of a shortcut. In class, I had the kids do this on their own, but I'm going to do it with you. First thing we want to do is factor this quadratic. 2x and x. Factors of 12. I think I'm going to want 4 and 3. It's going to be a +8, -3. That's what I want. Greater than or equal to 0. The zeros, the boundary points, I'm going to have 3/2 and -4. Now, the fact that that's a fraction doesn't matter a bit. I'm going to create my number line. put on my two numbers. Now this time, I kind of wanted to show you that f of 5, f of negative 5, f of 0, so that you knew, kind of could look back and see what are we doing? Well, what I'm doing here, this time instead of having to write that, I'm just going to put it right on my number line. I'm going to make my number line big enough that I have room to do that. I'm going to choose a number over here on the left. Let's say negative 5, and I'm going to plug it in here. That's going to be negative 10 minus 3. That's negative. Now when I plug negative 5 into the second quantity, that's also going to be negative. And a negative times a negative is going to be a positive. So instead of writing it off to the side and writing all that notation, I'm just going to do it right on my number line. I do want to see this on your number line. I know that you're going to get to the point where you can certainly do this in your head. That is going to be our goal eventually. But for right now, I do want to see this number line. So on your homework, that's what I'm going to be looking for when I stamp your green sheet, that you have your number lines and these signs in here. All right, 0. 0 here is going to be end up negative. 0 here is going to be a positive. A negative times a positive is going to be a negative. And last one, I got 3 halves. I'm going to put in 4. 4 here is going to end up positive. 4 here, going to end up positive. Positive times a positive is going to be a positive. Now this time, if you'll look, we are actually shooting for this to be greater than or equal to 0. So this time I want it to be positive. That's going to happen in this area, and it's going to happen in this area. So my solution is anything from negative infinity to negative 4. This time it's going to have a bracket because of the or equal to, in union with bracket 3 halves to infinity. Any value in these ranges would actually work in this inequality. Anything in here would end up making a false inequality. This problem is an example of where you might want to be using an inequality on a quadratic. It's that free fall motion formula again. If an object is launched from ground level, notice it's from ground level, so that's why there's no constant here, because that's a 0, with an initial velocity of 96 feet, which is already entered into the formula for you. Its height is measured after t seconds, given by this formula. See the negative 16, that's always there, always that coefficient. The question here is, when will the object be greater than 80 feet above ground? Well, this expression right here is representing my height, and I want this to be greater than 80. Well, I'm just going to set up the equation then. Negative 16t squared plus 96t, I want to be greater than 80. Subtract the 80 over, and I'm going to be factoring. Now, these are some pretty big numbers. I'm going to pull out a GCF. I know that, heck, I think 16 goes into all those. I'm going to pull out a negative 16. That's going to leave me with a t squared. 16 goes into 96 6 times, but I pulled out a negative, so it's going to be a negative 6t, and that's going to end up being a positive 5. Leave that negative 16 out there. It's going to be important. Factors of 5, got to be 5 and 1, negative, negative, going to get me my negative 6 I want, and I've got it. My critical numbers are going to be 1 and 5. What's different on this one is that I'm going to have 3 things to check, because I've got this quantity and this quantity, but I also have this negative 16 that it's being multiplied. And that's important because it's negative. When I'm taking this times this times this, now I've got 3 signs that I'm looking at, and the first sign is always going to be a negative. let's pick a number here. 0 would be easy. If I put a 0 here, it's going to be negative. I put a 0 here, it's going to be negative. And this is already negative. I've got negative, negative, negative. Now I'm going to do a 3. It's going to fall in the middle. Okay, the negative 16 is still there. Put a 3 in the first quantity. That's going to get a positive. Put a 3 in the second. Still going to stay negative. And then I'm going to put a 10 in, let's say. Then I'd have a negative 16, so it's a negative. Put a 10 in the first one. Put a 10 in the second one. Now, by doing that, I end up with this section being negative, this section being positive, because a negative times a positive times a negative would end up positive. This one's going to end up negative. Now, I feel like all of these examples I'm doing are alternating signs. I mean, they're alternating that positive, negative thing. You will find that that does not actually always happen, so don't get too used to that yet. Let's see. It appears that I am looking for this to be greater than 0. I want the positive. That means it's going to fall right in here. This one was not an or equal to, so I'm going to use parentheses. Anything from 1 to 5 would work in this inequality. Okay, now that's great, 1 to 5. But it is an application problem, and I would want you to explain what the heck did we just figure out? What is the 1 and 5? Well, the 1 and 5 are your t values, right? So that's your times, and your time is measured in seconds. You have determined that it is greater than 80 feet above ground between 1 and 5 seconds. So I box this in. I might undo that box because I would rather, maybe, I guess it's not going to let me undo. Nope. Okay. So my true answer is going to be to say that it will be above 80 feet. Instead of between, I might say from 1 to 5 seconds. And that's really my answer. And I'm going to kind of show you what I mean, what's going on in this. You know that this is a graph. It's an upside down parabola. It's gone up. It's coming back down. What you've done is you've determined that 80 feet is somewhere like right here. This is 80 feet. And this is 1 second. This is 5 seconds. And you are above the 80 from 1 to 5 seconds. That's what you just found. And it makes sense then that what I was shooting for was in this section in the middle. If I would have gotten answers out here, that would have been suspicious. Probably what this would be saying is when is the object below 80 feet? Then these outside values would make more sense. All right, the last thing, we're going to try a different type of graph or a different type of function, sorry. It's a rational instead of a quadratic, and we're still going to do the sign chart. And this is a nice example for if you don't know what the graph even looks like, what's going on with it, doesn't matter. You're just going to trust your sign chart. Our to-do list for this is to rewrite the inequality so that 0 is on one side. That's going to be important here because it's not always going to be the case. To determine your boundary points, you're going to determine what makes the numerator 0 and what makes the denominator 0. Those will be creating your boundary points this time instead of factoring. And then just like before, we're going to use a number line and then we're going to do test values. Let's jump in and try one. I want to solve this. The first thing I'm going to do is determine first thing I want to make sure the 0 is one side, and I'm being nice here because 0 is on this side, so that's good. Whatever makes the numerator 0 and the denominator 0 are your test points. So I can see here that if you set this equal to 0, add 1, divide by 2. 1/2 would be one of my boundary points, and the denominator would get me a 3. So I've got a 1/2 and a 3. One of the things you want to kind of keep in mind, this is a rational, and remember that whole thing with the domain, even though it's an inequality, we should still have an awareness of our domain. X cannot be 3. I've got my boundary points, got the number line drawn. Let's do some test points. Let's go ahead and pick a number down here. I'd say 0 would fit down here. If I put 0 here, I'd end up with a negative. Put 0 here, a negative. So the way I show that is it's going to be a negative over a negative. If I choose a value in the middle of these two boundary points, let's say I put in a 2, put a 2 here, that's going to end up positive. Put a 2 here, that's going to be negative. I'm going to have a positive over a negative. Last one, let's put in a 5 over here. And again, it doesn't matter. You could put in a 4, you could put in a 10, as long as it's on this side of 3. If I put a 5, I can tell this is positive and this is positive. From that, I know that this is going to get me a positive answer. This is going to get me a negative answer. This is going to get me a positive answer. Negative divided by a negative is positive. Positive divided by a negative is negative, and so forth. In this particular problem, we are looking for it to be less than 0. So I want this negative. This is going to be my answer in here. And I'm going to guess that you're going to want to write this right here. You know what? I need to fix this. And probably your notes, you maybe already noticed this because I've maybe already fixed this in your notes. This was intended to be an or equal to. So yours probably already has the less than or equal to. Let me fix mine so mine matches yours. If yours doesn't have that, then put the or equal to there. Maybe you have the older version. Okay. So because of the or equal to, that tells me I want to be using brackets. And I would say it works anywhere from 1/2 to 3 with brackets. However, don't write that. Wait. That's actually not accurate. And it would have been if I was doing a quadratic, but because I'm doing a rational and I have to be concerned with my domain, X can't be 3. Even though this is an or equal to, if X were 3, this would be undefined. I've got to get rid of this bracket. Don't just write over the top of it. The number of times I count off for a bracket with a parenthesis written over each other, I can't tell which one you really want. You've got to erase and fix. All right, so this is what I would want for an answer on that. All right, one more. This one does not have a 0 on the side, so let's talk through what do you do in that case. This again, you can see by this guy right here, this was a try it on their own. I'm just doing it with you. If I want this to be 0, you might write small on this. I'm going to write way over here. I'm going to have to subtract the 1. But our whole trick with the whole sign chart thing only works if this is a single fraction, and it is not. So I'm going to write the 1 over 1, and I have to get a common denominator to get these two things merged together. Common denominator will be x plus 4. Numerator is going to be a 5. And be careful because this negative right here has to distribute through. Negative x, negative 4. And last step, go ahead and clean it up. It's a 5 minus 4. That's going to simplify to 1 minus x over x plus 4. There we go. Looks like I'm going to be looking for the positive situation. Now we set up our number line with the critical points. The numerator, if x was 1, that would end up being 0. And your denominator, if x was negative 4. Now remember, on your domain, x cannot be negative 4. Don't let yourself put a bracket if there needs to be a parenthesis. Let's do some test points. This one's a little bit different because this feels backwards to me. We want to be careful with that. For instance, if I put in a -5, putting a -5 here actually becomes 1 minus -5, which is 1 plus 5, which is positive. Putting a -5 in the denominator is going to be a negative. Let's plug in 0. You're going to have a 1, which is positive, and then the denominator is also positive. Let's put in a 5 in your numerator. If this is a 5, 1 minus 5, that's going to be negative. And I'm writing, I don't know why I'm writing these next to each other. Really, you should be writing it probably like this to show my numerator is positive, denominator is negative, positive, positive. And again, 5 in the numerator, it's going to be negative, but my denominator is going to be positive. If I take a positive divided by a negative, it's going to be negative. Positive divided by positive, negative divided by positive. And as I mentioned earlier, we do want this to be greater than 0. I'm looking for this again. I'm getting lucky with this, always ended up being the middle one here. And I'm going to go from -4 to 1. It is another or equal to, so I'm going to put a bracket on the 1, but that whole -4 being in my denominator, I've got to stick with a parenthesis on that. And here is our answer. All right, I kind of like doing this sign charts, so hope you do too. Go start your assignment. Good luck.